4x minus 1, all in the exponent. Well, the derivative of an exponential is itself, so it would be e to the x squared plus 4x minus 1 times the derivative of the exponent. What's the derivative of x squared plus 4x minus 1? It's 2x plus 4. Did I cover this part? I did, right? But I said, then don't worry about it. It comes from this. If you have y equals e to the u, where u could be anything, like, in this case, it was x squared plus 4x minus 1. The derivative is itself times u prime. And in this last example, I put u prime on the left, but any questions? All right, you guys take the derivative of this now. Let's take a shot at it. Y equals e to the sine of x. So what kind of function is this? Is this an exponential function or a trig function? It's an exponential. It's the main function is e to the something, e to the u. So how do you take the derivative of e to the u? Is itself. That's the rule for e to the something. But now the chain rule times the derivative of u. What's the derivative of sine of x? Cosine of x. Does that make sense? All right. Now, well, what if I asked you to take the derivative of y equals, I don't know, 7 to the x cubed plus 5x. This is also an exponential function. It's 7 to the u. So go ahead and try this. So you're going to take the derivative of 7 to the u, but then it's a chain rule as well. So the derivative is going to be itself, but you're going to have times the ln of 7 as well because it's not an e. Now you got to use the chain rule. What's the derivative of u? It's derivative of x to the third plus 5x is 3x squared plus 5. Now, what order do I need to write these? It doesn't matter. You got 3 items here. This guy times this guy times this guy. Any order you put those 3 things, it doesn't matter. Just make sure you put the parentheses around each one like I did. All right, so now that you know how to do all these, let's do one more here. This is number 36 from section 3.4. Y equals x squared times e to the negative 1 over x. Now, before I have you do this, I'm going to give you a little tip on how to start it. What I would do is that negative 1 over x, I would rewrite this as y equals x squared times e to the negative the 1 over x part, I'm going to write it as x to the minus 1, because I know that's eventually I'm going to have to do something about that. So, and this is a multiplication sign here. All right, so go ahead and the main function here, it's a product. So you got to use the product rule. So go ahead and do this, then I'll do it in a couple minutes. Did you guys hear about the breaking news today? Texas governor said everything is open, mask mandate is gone, restaurants or businesses can go back to 100% capacity. So I'm moving to Texas this weekend. I'm going to get a cowboy hat and I'll fit right in. Lauren, the ceiling of your house looks lovely. Thank you. Damaris, you're not in Arizona anymore?
No, it was just for the week.
Oh, okay. Should have stayed there. It would have been probably better rules than here.
Actually, they kind of got to around the same as over here.
Oh, really?
Mm-hmm. Except at like Home Depot, they don't really care, but everywhere else, it's like.
Well, I mean, I don't mind. The thing is, like, it's a serious virus. So if someone wants to quarantine and there's certain things that they need, like let's say they need to go to the supermarket. So yeah, there they got to have social distancing and rules. But then some places, it's like, if I'm going to a bar, well, anyone that has underlying conditions should not be at a bar. They should be staying in their room. So you should just let that go. It's like free for all. Like, it's kind of like, if I go bungee jumping, I understand that that rope might break. So I don't go bungee jumping because I don't trust the rope.
Canada is actually with their students that they're transitioning for elementary and middle school. If one student in their class ends up having COVID, all the students have to quarantine away from their families even for 2 weeks.
Where is this at?
Canada.
Well, Canada, they're nuts. I just saw that if you're traveling, if you test positive, you got to be quarantined at a government facility, whatever that means. I thought that's what they call prison. But then if you're negative, you got to quarantine at home until, I don't know exactly the details, but glad I don't live in Canada.
Yeah, there's psycho up there.
Yeah, and then the other thing about politicians is, why the heck do I always have to see Bill Gates on the news? If I wanted my Microsoft Windows fixed, yes, that's who I want to see speak, Bill Gates. But I don't want him talking about health. All right, moving on. That's my rant for the day. Just like, you wouldn't seeing me advising you on how to fix your car. Moving on. So you got to use the product rule. First, times the derivative of the second. What's the derivative of e to the negative x to the minus 1? Well, derivative of e to the something is itself. And then that's times the derivative of the exponent. So that's the u. So remember, derivative of e to the u is itself times u prime. So what's the derivative of negative x to the minus 1? So let's see, negative 1 times negative, that's positive x to the minus 2, right? Because the negative 1 times the negative cancel out. Plus, so that's, we're still using the product rule, so that's first times the derivative of second plus second times the derivative of the first. What's the derivative of x squared? 2x. All right, and that's pretty much, now you could, this does simplify very nicely actually, because it's a problem from the book. So that x to the minus 2, if I drop it to the bottom, becomes x squared. So they actually will cancel out. And you can stop right here. The back of the book will probably factor out that e to the minus x to the minus 1 from each term and so on. But you get how to do it. Let's do one more here before we move on. This is going to be number 40 from the same section. For those of you who came in late, we're still doing section 3.4. We're just focusing on things that we skipped over. All right, y equals e to the sine of 2x plus sine of e to the 2x. So this is, I like this problem because you have to, so this first term, so think of this as two separate questions, first of all, because there's a plus sign. When it's a plus sign or a minus sign, you can just treat them as two separate questions. The first part, that's an exponential function. So this is an exponential. This is a sine function. So when it's an exponential, you use the rule on how to take the rule for taking the derivative of exponentials. When it's a sine function, you use the rule for taking the derivative of sines. So keep that in mind. And then, of course, you got to use the chain rule and so on. So you want to try this? Go ahead. Go. I will take a look at your ceilings while you're trying this. Here, you can look at my ceiling too. See, no popcorn ceiling. Oh, HRAM, where have you been? What you need a better lamp. Yeah, I don't even know how you look like this whole semester. Where are you at here today?
So like we don't have proper lighting in my room. There's just this.
Okay, can I see how you look like for a second at least?
Yeah.
My God.
I mean, and
Well,
this
at
is
least for a second, like get close to the camera.
Yeah, and this is with my blinds.
Okay, I know you don't have proper lighting in your room, but see that thing next to you? It's called a window. You can open the curtain and get some.
It's here. Let me show you. It's basically like the blinds are open. It's just that it's still super dark somehow. I
Okay.
can open them completely.
Well, whatever you prefer.
Is it any better? Still can't see anything, right?
No, I just see the shape of your head. That's it.
Made
It's
it
the
worse.
worst lighting camera combination I've ever seen in my life.
Yeah, I know. My apartment complex people are like, they cheap out in all the wrong areas. They couldn't provide like a central light or anything, like a light fixture. So I had to, that tube light is connected to an outlet.
You have running water? I'm sorry.
Believe it or not, like even like the washing machine doesn't work half the time.
I'm sorry. I'm sorry. I know I'm supposed to be more professional. I'm just joking around. Oh, okay. I swear I didn't have anything to drink before class. All right. Okay, so let's do this. Exponential function, the derivative of exponential is e itself, so it's e to the sine of 2x. Now, you got to take the derivative of sine of 2x. What's the derivative of sine of 2x? It's cosine of 2x. What's the derivative of 2x? 2. Do you see how I used the chain rule twice there? Because if I just said, hey, y equals sine of 2x, you know how to take the derivative of that. You would say, oh, that's cosine of 2x times the derivative of the inside, which is 2. So you had to take the derivative of e to the something, which was that. Then the derivative of sine of 2x is cosine of 2x times 2. All right, so that's done with the first term. Now, plus the second part. Now, the second part, that's a sine function. What's the derivative of sine? Cosine of u. So derivative of sine of u is cosine of u times the derivative of u. What's the derivative of e to the 2x? E to the 2x times the derivative of the exponent. What's the derivative of exponent? 2. We have to use the chain rule twice there as well. Does that make sense? Any questions? Yeah, so if I wanted to take the derivative of e to the 2x, it would be itself times the derivative of the exponent, which is 2. So in this last part, derivative of sine is cosine. So derivative of sine of u is cosine of u times the derivative of u. So in this case, the derivative of e to the 2x is e to the 2x times 2. Someone said, can I explain the last part? That's why I didn't do it. All right, and this is you can't really simplify much. I'm sure you can factor something out and so on, but that's it. All right, so now for section 3.4, you probably skipped over some of the problems when you did the homework because I didn't explain to you the exponential part. Well, now go ahead and try to do it, and you can ask me about more next time. So now we're going to go ahead and start section 3.5. Implicit differentiation. So, by the way, our next exam is March 25th, right before spring break. I'm going to be grading your exams right after. Part of the spring break, will be going to an undisclosed location. Don't email me. All right. So can you hear me? Say something in the chat. Yeah, my internet connection here is as good as her day's lighting in his room. Good. Okay. Well, you guys move or something. Move your head, tilt your head or something so I can see my videos moving. Okay. Madison, you look like one picture the whole time. Yeah, you're like smiling like this, and then you froze. Okay, let me know if, as long as you can hear me and see the iPad. Oh yeah, her day, yeah, you do. Like when you're playing a game and you can't choose that character at a particular game until you beat a certain level, then you unlock that character. What game it was? Probably a lot of games. All right. So implicit differentiation. So far in this class, whenever you've done derivatives, we've been taking the derivative explicitly. Like for example, y equals x squared. The derivative is 2x. Mainly it's dy over dx equals 2x. So let me try again here. If you have y equals x, so the key here is we're taking the derivative with respect to x. So the derivative of y with respect to x is dy over dx. The derivative of x with respect to x is just 1. So that's why, let me write the 1 here. So it's just equal to 1. So you're probably wondering why does x get a different treatment than y? So when we take a derivative in an equation, we're going to take the derivative of x, it's going to be 1, but the derivative of y will be dy over dx. So let me explain that. Now we're going to do implicit differentiation. So find dy over dx by implicit differentiation. It's implicit because it's not in the form of y equals something like you're used to, or f of x equals. It's going to be something, some equation, everything mixed together like that. X squared plus y squared equals 25. Can you guys still see my writing okay? Everything looks good and my audio was okay?
Yeah, pretty good.
Okay, okay. So I can't see your reactions right now because half of you are like frozen, some of you are moving choppy. So if you have a question, just type it in the chat or say something. I can't tell by your expressions. Okay, so we're going to take the derivative of both sides with respect to x. So the derivative of x squared is going to be 2x. The derivative of y squared is going to be 2y, but then the chain rule times the derivative of y. What's the derivative of y? Well, we don't know. I don't even know what y is. So we call it dy over dx. Before we knew what y is. Hey, y is equal to this times this. But we're going to equals, what's the derivative of 25? 0. So I know that part throws people off there. We'll discuss it more. So the derivative of x squared is 2x, but the derivative of y squared, why isn't that just 2y? Why is it 2y times dy over dx? Because we're taking the derivative with respect to x. Think of it like this. If I asked you to take the derivative of something squared, you would say, all right, it's 2 times that something times the derivative of what's inside. Normally, you know what the derivative of the inside is. Here, it's y. Well, what's the derivative of y? I have no idea what y is. I could have solved for y in this case, but some other problems and later you won't even be able to solve for y. So you just call it dy over dx. It's like to be determined. All right, so now, once you get to this step, now you just solve for dy over dx. So we're going to go minus 2x from each side. Divide both sides by 2y. Twos cancel out. Negative x over y. Now, notice the answer here has x's and y's in it. Well, it actually depends on both because I chose an easy example here because x squared plus y squared equals 25. I can show you the graph. So in this case, this is the graph where x squared plus y squared equals 25. It's a circle centered at 0, 0 with a radius of 5. So I couldn't ask you here, hey, what's the slope of the tangent line at x equals 3? Because you would say, well, what do you mean at x equals 3? Do you mean this line? Or do you mean this line? Because they're both at x equals 3. So I have to tell you both the x and the y values. So, and you can see it's dependent on both because it's not a function. It's just an equation. There's a relation. So you take the derivative implicitly. We're going to do more. So give me a second. All right, so find the slope of the tangent line at the point 2x squared minus 3y to the third equals 5 at the point negative 2, negative 1. So the derivative of 2x squared is 4x. So let me actually, I'll do the answer in blue. So the black, that's the question. What's the derivative of 3y to the third? Well, power rule, 3 times 3 is 9y to the second times the derivative of y. What's the derivative of y? I don't know. We call it dy over dx. It's kind of like this. If I were to ask you what's the derivative of 3 times something third, you would say, oh, that's 9 times.
You're breaking up, Professor.
Second. That's a of y. I don't know. So we call it dy over dx. Figure it out.
Professor, you cut
All
off
right.
for an
Equals
entire,
the
like,
derivative
20
of 5.
seconds.
Don't forget to take the derivative of 5. Hold on. What happened?
You cut out throughout that whole explanation.
Yeah.
That's